Today we're going to talk about simplifying radical expressions and solving quadratics using the square root method. So the reason why we're doing this together is because radical expressions are very similar to, it's all using square roots, and we need to remember square roots and what goes on with square roots in order to do the square root method. So square roots are examples of radicals or radical expressions. Radical expressions and are often used when solving quadratics. Radical expressions is an expression with a radical sign. If no root index is shown, such as the square root of 49, it is assumed to be 2 or a square root. So what we're saying is over here, this is the root index. If there's not a number for n, then you assume it's 2. This is the radical sign. And this is the radicand. Radicand. When simplifying a square root, list the principal or the positive square root. So when we find the answer to a square root problem, or we take the square root, we need to remember that there's 2 possible answers. Like if I said the square root of 4, well, if I take 2 times 2, well, that equals 4. But so does negative 2 times negative 2. Sorry for the bell. So know that those are positive. To simplify radical expressions, we can use the product property of square roots shown below. Assuming a and b are positive real numbers, the following is true. The square root a times b, so this equals the square root of a times the square root of b. Using the fact that the square root of 100 equals 10, we're going to rewrite 100 as a product of a perfect square. Factors to demonstrate the property. So looking at 25 times 4, that's we know is equal to 100. The square root of 25 equals 5, and the square root of 4 equals 2. 5 times 2 is 10. So we're really playing with our multiplication. A square root radical expression is simplified when the radicand, so this is the important part, this is where the assignments come in, is simplified when the radicand, or the number inside the radical sign, has no perfect square factors other than 1. 15 is in its simplest form because none of the factors of 15 are perfect squares. We've got 3 and 5 and 1 and 15. The square root of 12 is not in its simplest form because one of its factors, 4, is a perfect square. So we could take that out. So we're going to complete the table of these perfect squares so you have that for your reference. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 36, 49, 64, 81, and 100. I would go ahead and also add to your notes if you are not comfortable with like 11, 12, 13, and 14, and 15. You might go ahead and write those those perfect squares down as well. So we're going to look to see if these are simplified. We're going to look at our factors and determine if it's simplified or not. We're not actually going to simplify yet. So factors of 27, we have, if you want to do your T-chart like we did, we're not going to look at this part right now, but 27 was 1 and 27, 2 no, 3 and 9. So our factors are 1, 3, 9, and 27. Well, I know for a fact that it's not simplified because 9 is a perfect square, so it is not simplified. Look at 38. 1 and 38, 2 and 19. Well, my factors are 1, 2, 19, and 38. None of those are perfect squares. So yes, that is a simplified radical. 125. Well, my factors are 1, 5, 25, and 125. Well, this one right there is a perfect square, so it is not simplified. So you might be wondering, okay, how do we simplify? That's going to be the next steps. Determining if it's simplified or not is step 1. The next is actually going to be taking that and simplifying it. We can use the product property of square roots and our knowledge of perfect square factors to simplify radical expressions with the steps below. You're going to find the largest perfect square factor of the radicand. Rewrite the radicand as a product using the perfect square factor and the product property. Take the square root of any perfect square. Okay, so we're going to simplify 24. We know that 4 times 6 equals 24. So we're rewriting that as, so this was the square root of AB. Now we're going to write square root of A times square root of B. So we know, oh, not 4. Take the square root. We're going to do the positive or the principal root. 2 square root of 6 is a simplified version of the square root of 24. So, looking at 48. Well, we've got 48, 1 and 48, 2, that would be 24, 3 times 3 times 16. I can go ahead and stop here actually because I see a perfect square and I know that that's going to be my largest perfect square. So I'm going to rewrite this as the product. So square root of 48 equals the square root of 3 times the square root of 16. Well, I know the square root of 16 is 4, so my simplified answer is 4 square root of 3. Okay. 300 and the square root of 300. I can already tell that I'm going to have 3 times 100 because 100 is a perfect square and it's not going to get any larger. So square root of 3 times the square root of 100. Simplified down, that would be 10 square root of 3. 2 square root of 45. So already we're saying 2 times the square root of 45. But I know my factors of 45, and I know 9 times 5. So 2 times square root of 9 times the square root of 5. And the reason why I know that is because I know that 9 is a perfect square, and it's the largest perfect square factor. So that's 2 times 3 times the square root of 5. So 6 times the square root of 5 is my answer. So that is simplifying radical expressions. And the first part of your IND and exit tickets will be covering this. But let's go ahead and talk about the square root method. The square root method is another way to solve quadratic equations. One of the things to think about if you're ever confused on this is think about how you solve Pythagorean theorem. If going back to your last class and we talked about Pythagorean theorem and a squared plus b squared equals c squared. Well, if you didn't know one of those, you had to solve, and your last step to solve to get the variable by itself was to take the square root of both sides. And that's pretty much what we're going to be doing today on this. So when simplifying a square root expression, we typically give the positive root called the principal square root, like we did for the simplifying. However, when solving a quadratic equation, by taking a square root, we want to list all possible solutions. We're going to find the solutions for each equation below. So remember, this is taking the square root of both sides. So x equals 5 and x equals -5, because it could be either one of those options. So if we were solving this on a graph, our zeros, our x-intercepts, would be at 5 and -5. Okay, same thing here. We're going to have x equals 9 and x equals -9. X equals 15 and x equals -15. So, using the square root method involves taking the square root of both sides of the equation to isolate the variable. The table at the right describes a few situations when the method works well. So these are the situations that you would want to use the square root method over a different method. The x squared is set equal to a value. So on solving using factoring, we wanted it equal to 0. On this one, we want it equal to a number. The middle term is missing, or there's a binomial squared. So we're going to practice each of these methods right here. And then this will be the end of our notes after we do this. So if you have more questions on it, we can work on the practice together in class, or I can help you with the assignments. So one of the things that I think makes square root method easiest is to go ahead and make this first situation true. Make it to where it's not equal to 0. So I'm going to add 100 to both sides. X squared equals 100. So I'm going to take the square root of both sides. X equals 10 and x equals -10. Same thing here. Plus 8 cancels out. 4x squared equals 8. I'm going to take the square root of both. So this is going to be the square root of 8, which equals, this is where simplifying radicals is still playing a part. So we know that's the square root of 2 times 4. So simplifying that out, that's 2 square root of 2. And if I simplify this, this is 2x equals 2 to the square root of 2. I want x by itself, so I'm going to divide by 2 on both sides. Those cancel out, that equals 1, 2 divided by 2. Same thing here, those simplify. So x equals plus or minus, because remember there's both the positive and the negative, square root of 2. Over here, this one's a little simpler because 1, it's already equal to a number, square root of both sides. The square root and the square cancel. So that leaves me with x plus 5 equals 7, and x plus 5 equals -7. Remember that it's both of them. I'm going to subtract 5 to solve for x. Those cancel out. -5 here, -5 here. Not 7. Why did I write 7? It's 12. -12. There we go. I know why I wrote 7. I was thinking ahead of the answer. So x equals 7 and x equals -17. So those are my two squares. So that is the square root method and simplifying radicals, I'm sorry.